Okay, when I say the word asteroid, what's the first thing that pops into your head? For most of us, it's probably some giant scary rock, doomsday movie style, hurtling right for Earth. But what if I told you that's kind of the boring way to look at them? Today, we're going to completely flip that idea on its head. Forget scary rocks. Think cosmic treasure. So let's start the hunt.
So let's get right to it. Are asteroids really just space junk? Are they nothing more than dangerous obstacles floating around out there? Well, sure they can be, but that is not the whole story. Not even close. In fact, it's not even the most interesting part of their story.
A much better way to think about them? Imagine their puzzle pieces. Yeah, puzzle pieces. They are the fascinating leftover bits from when our entire solar system was first being built. It's like finding ancient artifacts from a time before the planets were even finished. All right, so if they're puzzle pieces, where did they come from? To figure that out, we got to jump in a time machine and rewind the clock way back, like 4.6 billion years back. Okay, so picture this. The early solar system wasn't neat and tidy. No, it was a massive, chaotic, cosmic construction site. You've got this giant cloud of gas and dust just swirling around. Think of it like cake batter being mixed in a giant bowl. And little by little, bits of that batter started clumping together, forming the planets we know and love today. But here's the thing, not all of that batter made it into the final cake. See, you had Jupiter, the absolute giant, the bully of the solar system. Its massive gravity was constantly stirring the pot, making it impossible for a whole chunk of that material to stick together. So instead of forming a planet, these pieces just got tossed around, kind of like popcorn kernels bouncing around in a hot pan. And that, right there, is what an asteroid is. It's a leftover piece, a failed planet. And when I say leftovers, I mean a lot of leftovers. Get this. Scientists figure there are more than 1 million asteroids out there that are bigger than a kilometer wide. 1 million! That is just an enormous inventory of ancient material just floating around waiting for us to check it out. Okay, so we know where they came from. Now it's time to take inventory. I mean, if we're on a cosmic treasure hunt, we need to know what the treasure actually is, right? So what are these space rocks all about? First off, they come in pretty much every size you can imagine. On the small end, you've got stuff that's basically just gravel you'd find in your backyard. But then you have the big one, the king of the asteroids, a dwarf planet called Ceres. And this thing is massive. We're talking 940 kilometers wide. To give you an idea, that's about the size of Texas. A Texas-sized rock floating in space. Wow. And another thing you'll notice, most of them are not perfectly round. They're not like little planets. See, they just aren't big enough for their own gravity to squish them into a nice, neat sphere. So instead, they look like lumpy potatoes, battered and dented from billions of years of just bumping into each other out there in the cosmic demolition derby. All right, let's talk about what they're actually made of. This is where it gets really interesting. First, you've got your S-types, which stands for stony, and they're pretty much what they sound like, giant floating boulders. They're made of the same kind of rocky stuff you find right here on Earth's crust, which, by the way, makes them perfect building materials for the future. Next up, we have the ammontypes, M for metallic. And okay, this is where the treasure hunt really kicks into high gear. These things are loaded with metals, iron, nickel, and yeah, even precious stuff like platinum and gold. We're talking about a space miner's absolute dream.
And last but not least, you have the C-types. C for carbon-rich. You can think of these as kind of like giant frozen mud balls. But inside, that's where the good stuff is. Water ice and even organic compounds, the actual building blocks of life. And that water, in space, that's liquid gold. It's drinking water for astronauts, or you can even split it into hydrogen and oxygen to make rocket fuel.
So here's a really easy way to keep all this straight. Just think of a kitchen pantry, right? The rocky S-types are your cans beans, the basic stuff you need to build. The metallic M-types, those are your bars of chocolate, the really valuable goodies. And the icy C-types are your frozen veggies, the essential resources you need to survive out there. And you know, we've actually visited some of these cosmic potatoes up close. We've seen Vesta, which looks like someone took a giant bite out of it. We literally landed a spacecraft on Eros, which is shaped like a peanut. And get this, just recently, NASA brought back actual, physical samples from an asteroid named Bennu. We have a piece of a 4.6 billion-year-old rock right here on Earth to study. How cool is that? So that's all great, but how do we even find these things? They're tiny specks scattered across millions and millions of miles of empty space. Well, you might be surprised to hear that the hunt doesn't start in a spaceship.
It starts right here on the ground.
We use these incredibly powerful telescopes to spot them. To us, they just look like tiny little dots of light moving ever so slightly against the background of stars. But by studying that faint light, and even by bouncing radar signals off them, kind of like a cosmic sonar, we can figure out their shape, their size, and even get a really good idea of what they're made of. All of this without ever leaving home. It's pretty amazing how we've turned these distant, mysterious objects into our known neighbors.
Okay, so we can find them, we can track them, we know what they're made of. But so what? Why does any of this matter? Well, this is where the story takes a turn, from astronomy to a potential space gold rush.
Look, these things aren't just rocks, they are floating resource depots. Think about it. Those M-type metallic asteroids. A single one could hold more platinum than has been mined in the entire history of Earth. The ICC types? That water can be turned into drinking water for astronauts, sure, but even more important, you can split it into hydrogen and oxygen. And what's that? Rocket fuel. We're talking about setting up interstellar gas stations, refueling missions in deep space so we can go farther than ever before. This isn't just a science experiment anymore. This is the foundation for a whole new off-world economy.
So it's time we completely change how we think about them. They aren't trash. They aren't junk. The best way to put it is this simple phrase. They're resource hubs. That's what they are. They're the future gas stations, the hardware stores, and the water fountains of the solar system.
And all of this leaves us with one final really big question. When you add it all up, the potential for fuel, for building materials, for priceless metals, and what they can teach us about where we came from, you really have to wonder, could these little leftover puzzle pieces from the dawn of time, could they actually be the key to unlocking humanity's entire future in space? It's something to think about for sure.